Is the screen sharing better for everyone? Am I audible better? Clear? Am I audible to everyone? Chalo, very good. Let us try to start with the next topic better. Mechanical properties of fluids. That is fluid statics part of relation. Fluid statics and dynamics, we have hardly one question better. So the chapter is very big, but still you need to have an idea how to do the numericals related to them. Okay, so let us try to start with your new topic, fluid mechanics. Fluid mechanics. Okay, so see better in fluid mechanics, we'll be talking about two topics better. One is about your statics, another one is about your dynamics part. Okay, are you able to listen me? Chalo, very clear. So in this one, we are going to talk about your two topics in this chapter. One is about your fluid statics. One is about your fluid statics. Another one is about your fluid dynamics. Okay. In the first two sessions, we'll be trying to talk about your fluid statics only better. Fluid statics is nothing but static itself clearly indicates that we talk about your liquids which are at your rest. When the liquid is at rest, what is the forces acting on that one? Or when the liquid is being moving in a container which is been accelerating up, down, in a lift with a spring, different cases, but liquid is remaining constant. Liquid is not moving, but we are talking about a liquid in a container and container is moving. That all the things we will be talking about in the statics part of relation. So fluid statics is nothing but about your study of behavior of liquid at rest, at your rest. Clear better? So we are talking about the study of behavior of the liquid at your rest part of relation. And in this one, we talk about your study of behavior of liquid when in motion. When in motion. Clear better? That means in this one, we'll be talking about your equation of continuity. Equation of your continuity. Bernoulli's theorem, etc. And in this statics, we'll be talking about your Archimedes principle of your buoyancy, isn't it? Or Archimedes principle, or fluid at your rest part, or container with your motion. Container with acceleration. Clear, beta? Is it clear for everyone? So we are talking about your fluid statics and your fluid dynamics. In fluid statics, we will be talking about the study of behavior of the liquids at your rest. In this one, we'll be talking about your fluid Archimedes principles and container in a liquid with they are been accelerating up, down, sideways with certain angles, blah blah conditions. Whereas in the fluid dynamics, we're talking about the study of behavior of the liquid when in motion, like equation of continuity, Bernoulli's theorem, Venturi meter, etc. part of relation. Clear? So before that one, we'll be talking about in the first thing in this one is density. The first topic, what we are talking about in this one is your density. Represented by letter rho. Density is nothing but how much better? What do you mean by density? Density is nothing but what? Mass per unit length. This one is your mass per unit length. Mass per your unit length. Are you able to see the screen better, everyone? Mass per your unit length is your density. That means density is equals to your mass by your volume. Mass divided by your volume. Represented by V. So density is equals to your mass by your volume. This is the first formula in the hydrostatics. What you need to remember. Rho is equals to mass by your volume. Okay. What are the units of this one, beta? Can anyone tell me what are the units of this one? So if I'm talking about your SI units of this one, density is measured in your kg, mass is measured in your kg, and volume is measured in your meter. So the first unit is kg meter inverse. And the CGS unit of this one is CGS unit is kg will be measured in gram and meter will be measured in centimeters. It is your gram per your centimeter inverse. And we know that relation in this one 1 gram per 1 gram per centimeter cube will be equal to 10 to the power of 3 kg meter inverse cube. This conversion is very important. You need to remember better. 1 gram centimeter inverse cube is equals to 10 power 3 kg meter inverse cube. Density of your water is generally taken as 1 gram per cc beta. That is equals to your 10 to the power of 3 kg per meter cube. So in CGS unit it is 1 and in SI system it is your 10 to the power of 3, that is 1000. Density of your mercury is equals to 13.6 gram per cc in CGS unit, or it is 13600 kg per meter cube in your SI system. Clear? These are the data you need to always remember better. Okay, density of water is 1 gram per cc and r 10 to the power of 3 kg per meter cube. This is your SI unit. This is your SI unit. Okay, so this one is your SI unit and this one is your CGS unit. Okay, this one is your CGS unit and this one is your SI unit. Clear, beta? So density is equals to mass by volume. Our unit is kg per meter or it is gram per centimeter cube. 1 gram per centimeter cube will be equal to your 1 gram per centimeter cube will be equal to your how much beta? 1 gram per your centimeter cube is equals to 10 to the power of your 3 kg per meter cube. Clear for everyone? Clear beta? Okay, so the first formula what you are doing in this one is mass per unit length, that is your density. Density is equals to mass by volume. Unit is kg per meter or gram per centimeter inverse. Clear? Sure. Next one is relative density. Relative density. Next topic is relative density, or in the bracket you can write specific gravity. Specific gravity. The other name for this one is specific gravity. Okay. So what is you mean by relative density? Whether we are talking about relative density or your specific gravity, one and the same beta. That will be equal to your density of your substance. Density of your substance divided by density of your water. Density of your water at your 4 degrees centigrade. Clear beta? So what do you mean by relative density? Relative density is equals to density of your substance divided by density of water at your 4 degrees centigrade part of relation. Clear? So this is your basic formula you need to remember. Or else I can even write relative density is equals to, it is also equal to your density of your solid divided by density of your water. Density of your water. That is another form. That means relative density is equals to your density of solid divided by density of water. These are three different forms by which you can write the relative density. So relative density is also called as specific gravity, that is equals to your density of substance divided by density of water. Or else it is also called as of your relative density is also called as of your density of solid divided by density of your water. So mathematically for doing the numericals, we'll be writing that one as relative density is equals to your density of solid divided by density of your water. Is that clear? Both of them are the ratio of the densities. So relative density of the liquid, relative density of your liquid is equals to what will be the units beta? Density of the liquid will be relative density of the liquid, or relative density doesn't have any units, you can say. Relative density doesn't have any units. So I can just write one word, that one here. It has no units. It has no units. Clear, beta? Is that clear? In CGS system, you can write here, in CGS system, density of water is equals to 1 gram per cubic centimeter cube. So therefore, I can say that relative density will be equal to your density of substance. So density of substance is equals to the relative density if you are talking about in terms of density of your water in your CGS system. So density of water, if you are taking CGS system, relative density is also be called as of your density of your substance. Is it clear for everyone? It has no units because it is a ratio of two units or two densities only. So it doesn't have any units for that one, even no dimensions for that one. Clear for everyone? In CGS system, relative density of water is 1 gram per cc. So I can say that relative density will be equal to density of your solid. Sure. Next one. See here. If two liquids of masses m1 comma m2 comma densities rho1 and rho2, densities rho1 and rho2, and volumes v1 and v2 are mixed in a container, then density of mixture is, density of your mixture is given by, so right here, density of your mixture will be equal to your total mass divided by total volume, Okay, so if two liquids of masses m1 and m2, densities rho1 and rho2, and volumes v1 and v2 are mixed in a container, then density of the mixture is always calculated by the formula. Density of your mixture is equals to your total mass divided by total volume. That means I can write here, density of your mixture will be equal to, total mass will be m1 plus of your m2 divided by v1 plus of your v2. Or else I can even write mass is given in terms of v1 rho1 plus of your v2 rho2 divided by v1 plus v2. Or else I can even write this one as m1 plus of your m2. This one is your m1 plus of your m2 divided by, we can write in terms of mass and density, because it is m1 divided by rho1 plus of your m2 divided by rho2. Okay, so this is your basic form in which I can write the densities. So density of mixture is equals to your m1 plus m2 divided by v1 plus v2. If mass are not given and volume and densities are given, so mass I can write in terms of your v1 rho1 plus v2 rho2 divided by v1 plus v2. Or else if masses are being given and volumes are not given, then volumes you can write in terms of mass and density. So it is m1 rho1 plus m2 into your rho2. Is it clear, beta? Any doubt in this one to anyone? Any doubt? Any doubt in this one? Once again, so what we are talking about? We are talking about your fluid statics and we are talking about your fluid dynamics. In first 2 days, we'll be talking about only fluid statics beta. Fluid statics is nothing but study of behavior of the liquidity or rest. Or else I can say that in this one, we'll be studying about your Archimedes principle and your containers with which it is been accelerating. The next one is in the statics. The first definition which you should know is about your density. Density is nothing but mass per unit length. Okay, so m by v, SI unit kg per meter, CGS unit gram per centimeter cube. Very important thing is the conversion. 1 gram per centimeter cube is equals to 10 to the power of 3 kg per meter cube. Density of water is 1 gram per cc or 10 power 3 kg per meter cube. Density of mercury is 13.6 gram per cc in CGS system. In SI system it is 13600 kg per meter cube. The next one is relative density, density of substance divided by density of water at 4 degrees centigrade. And if two liquids are being mixed with different masses, different density, different volume, the density of mixture is total mass by total volume. So let us try to take some cases in this one. Case number 1. Okay, if masses are same, if M1 is equals to your M2, then density of your mixture will be equal to your 2 times of rho 1 rho 2 divided by rho 1 plus of your rho 2. I can say that it is an harmonic mean of your rho 1 and rho 2. Clear, beta? The same way. Case number 2. Case number 2. If volumes are same, if V1 is equals to your V2, then density of your mixture will be equal to your rho 1 plus rho 2 divided by 2. Clear, beta? That means it is your arithmetic mean of your rho 1 and your rho 2, beta. Clear? There is a different cases you need to remember in this one. Clear? So let me do one or two numericals. See this question, beta. Two different liquids when mixed in equal ratio, when mixed in equal masses, comma, density of your mixture is equals to some value, whatever we want to take, we can take that value there basically. Like say for example, density of your mixture is equals to your 3. I'm taking some rough value, beta. Density of mixture is equals to 3 if they mix in equal volumes, density of your mixture is equals to 4. My question is, find the values of densities of two liquids. Densities of your two liquids. Can anyone try it? Direct question. Just now I told you. When equal masses and equal densities. Two different liquids we are taking right now there. We are taking two different liquids. Okay. So we are taking two different liquids which are being mixed with your equal masses. First one is about your equal masses. Let me check the change. Yeah. First one is with your equal masses. The relative density of mixture is 3. If they are mixed with equal volumes, then density of mixture is 4. So I can use the first formula. Density of your mixture will be equal to your 2 times of your rho 1 rho 2 divided by rho 1 plus rho 2. Density of mixture is given how much for me? 3. Clear, beta? The next one. And the density of your mixture when they are mixed with equal volumes, that will be equal to rho 1 plus rho 2 divided by 2. That is equals to your 4. Okay. So therefore I can say that rho 1 plus rho 2 will be equal to 4 into 2, that will be equal to your 8. So that is my equation number 1. And rho 1 and rho 2 is equal to how much, beta? Therefore I can say that 2 times of rho 1 rho 2, this rho 1 plus rho 2 is nothing but 8. So this will become how much for me, beta? That will become for me 2 times of rho 1 rho 2 divided by rho 1 plus rho 2 is 8, that is equals to 3. 2 1s are 2 4s are 8. 4 3s are 12. That means rho 1 into rho 2 will be equal to your 12. This is my equation number 2. Done, beta? So solving the equation 1 and 2, I'll be getting the answer. Can anyone tell me what will be the answer, beta, for that one? Anyone? Solve the equation 190, you will get the values of your rho 1 and rho 2. Nandini? How many of you are giving the answer? I can't get the answer, sir. Can you solve it? Okay, fine. Rho 1 plus rho 2 is 8 and rho 1 and rho 2 is your 12 beta. Okay, now we have got these two equations. So I'm using this basic mathematics here. See, this basic maths you need to use. That is a minus b whole square will be equal to your a plus b whole square minus 4 times of your ab. Okay, a is nothing but here rho 1 minus of rho 2 whole square will be equal to rho 1 plus rho 2 whole square minus 4 times of rho 1 into your rho 2. Isn't it? So rho 1 minus rho 2 we need to calculate right now. So that will be equal to rho 1 plus rho 2 is how much better? See in the problem, rho 1 plus rho 2. Rho 1 plus rho 2 is 8. So that will be equal to your how much for me better? How much I'm getting? 8 whole square minus 4 into rho 1 into rho 2 is how much? 12. 8 8 is a 64. 64 minus this one is 4 into 12. How much better? 4 into a 12. So how much I'll be getting? 64 into 12, 16. So this will be your 16. So therefore I can say that rho 1 minus rho 2 will be equal to how much? 4. Okay. So as rho 1 plus rho 2 is equals to, right here, rho 1 plus rho 2 is equals to how much beta? 8. For solve these two equations, you will get the answer for this one beta. So if I'm solving these two equations, I'll be getting right now, this is positive, this is negative. That will get cancelled right now. That means we'll be getting 2 times of your rho 1 will be equal to how much for me beta? How much? Got an idea how to do it? Very good. 48. How 48 beta? Solve this two beta. Solving this, we get rho 1 value is equals to how much? Can anyone tell me? Exactly. Because this one and this one will get cancelled. So 2 rho 1 will be equal to your 8, 9, 10, and 12. So it is 2 rho 1 is equals to 8, 9, 10, 11, 12. This is 12, 2 1s are 2 6s are. So rho 1 is equals to 6. If rho 1 is equals to 6, then rho 2 I can calculate na beta. As rho 1 minus rho 2 is equals to 4. Rho 1 is 6 minus rho 2 is equals to 4. Then rho 2 will be equal to your how much? Can anyone? 2. What an idea. How do you do this one? Is the calculation clear for everyone? Very good. Rho 2 is equals to 8. Nandini, see the calculation. I'm not seeing it in you. Rho 1 is equals to 6. I got rho 1 is equals to 6. Am I correct? Nandini. Yes, sir. Okay, chalo, very good. So this is the basic maths which you need to keep in mind, beta. A minus B whole square is equals to your A plus B whole square minus 4 into your AB. Clear, beta? Any doubt in this one to anyone? Clear? Sure, very good. Next one. Pressure of fluid. Pressure of your fluid. Clear? Sure. Pressure of your fluid represented by letter P. Represented by letter P. Beta? I'm able to see her in the screen. Yeah. Okay. Sure. Pressure of your fluid that is represented by P. How do you write the pressure, beta? Pressure is equals to normal force divided by area. Isn't it? Pressure is equals to normal force by your area. That means the force should always be exerting normal onto the container. Like say for example, if there is a container like this, on this one there will be a pressure which is acting exactly perpendicular to the area. So perpendicular to the area, we need to apply the pressure. That is your delta F. Okay, normal force divided by area. So pressure is equals to your delta F divided by delta A. Pressure is equals to delta F divided by your unit is Newton per meter square, also called as of your 1 Pascal. Also called as of what? 1 Pascal. So SI unit is Newton per meter square. So I can say that 1 Newton meter inverse square is equals to 1 Pascal, represented by letter PA. PA is the unit of that one, but in the same way, 1 Newton meter inverse square is also equal to 10 dyne centimeter inverse square. 10 dyne centimeter inverse square part of relation. Clear, beta? Okay, 1 Newton per meter square is also equal to 110 dyne per centimeter square. In terms of atmospheric pressure, if I am writing, see the pressure whenever you are writing beta, whenever there is a force which has been acting on that one, reaction force, if it is making some angle, you try to resolve it and take the component which is in the direction perpendicular to the area. Isn't it? If the force is being applied on any body making an angle, then you try to resolve that force into the components and try to take the component which has been perpendicular to the area of your cross section. Okay, and you know that 1 atmospheric pressure is equal to how much, beta? 1 atmospheric pressure. 1 atmospheric pressure is represented by 1 atm. So I can say that 1 atmospheric pressure is equals to your, or represented by your P naught. So this P naught value is equals to your 1.013 into 10 to the power of 5 Pascal. For calculation purposes, we will be taking this one as equal to 10 to the power of 5 Pascal PA. P naught is equals to 10 to the power of 5 Pascal. Clear, beta? So I can say that 1 Pascal will be equal to your 1 Newton meter inverse square, or that is equals to 10 dyne centimeter inverse square. 1 atmospheric pressure is equals to 10 to the power of 5 Pascals. Is it clear for everyone, beta? I'm not doing the derivations for all the cases because we don't have the time to do in Go for the depth of this one. So directly applications and their applications for solving of your numericals. Clear, beta? So pressure of the fluid is equals to your pressure is equals to normal force divided by area. So P is equals to delta F divided by delta A. Unit is Newton per meter square, that is 1 Pascal. And 1 atmospheric pressure is represented by 1 atm. 1 atm is nothing but P naught. P naught value is 1.013 into 10 to the power of 5 Pascal. Or directly I can take for calculation purpose, P naught is equals to 10 to the power of 5 Pascals. Clear for everyone? So next slide heading, I'll take it here. Pressure variation with depth. Pressure variation with depth. Pressure variation with your depth. Okay. See, I'm not doing the derivation better. That derivation already has been done by you already while doing in your first year part. So with respect to the depth, that means like say if I'm taking this one as of your container and liquid is being filled in this one up to a certain height. Okay, so if I take some small cylindrical element in this one like this, small shape, some part. So there will be one force here right now, F1, one force of this liquid which is exerting from the downward. This is your height of this one, that is nothing but of your H. So pressure exerted by this liquid is being calculated by the formula. P is equals to your H rho G. I hope you remember this relation better. Are you clear with this one? Atmospheric pressure, if I'm writing right now, atmospheric pressure per deflation, pressure at your point A or whatever the given conditions you are taking right now. So two pressures will be acting. One is an upper part and below one is of your lower part. So pressure differences if I'm taking the relation from one point to your another point. So simplify it and write the relation. What is the pressure relation, beta? Can anyone tell me? This is getting stuck unnecessarily. Let me check it out. Yeah. Pressure with respect to your height. First one is open to the atmosphere beta. Next one is right now at a certain depth, isn't it? So with respect to your H, if I'm writing atmospheric pressure will be equal to your. This one is say for example P1 and this one is say for example P2. Okay. So it is right now P2 minus of your P1 will be equal to your H rho into G. Okay. P1 is open to the atmosphere. So P1 I can take it as of your atmospheric pressure. So P2 minus of P naught is equals to H into rho into G. So therefore I can write pressure at point 2 will be equal to atmospheric pressure plus H into rho into your G. So that will be the relation. Done, beta? Atmospheric pressure plus of your H rho into G. This pressure is known as this one. Or else I can write this one P2 minus P1 is also called as of your gauge pressure, beta. So this P2 is known as of your absolute pressure. It is called as of your absolute pressure. Okay, the same way P2 minus of P naught is equals to H rho G. This P2 minus of your P naught is equals to your H rho G is known as of your gauge pressure. Is known as of your gauge pressure. Clear, beta? Is it clear? P2 is your absolute pressure. P2 minus of P naught is known as of your gauge pressure. That means only by liquid pressure exerted by only by your liquid. Only by liquid. That is called as of your gauge pressure. Clear? Any doubt in this one? Sure. So pressure variation with the depth, if I'm writing P2 minus of your P1. See, as you're going into the water, the pressure goes on increases. That is the reason we are writing here higher value minus lower value. We have a detailed derivation for this one, but it is of no use for us right now. That is the reason I'm skipping the derivation. Clear, beta? Clear? Battery power is over. Sure. Next one. Exciting. Force on solid boundaries. Done, better. Charging is over. I'm just waiting for 2 minutes. This is some surface beta, and it is open to the atmosphere. So this is your atmospheric pressure. Height is filled up to your liquid, say for example of your H. And the area of cross section of this one is A. This one is your bottom, and width of this one is, say for example, some B. Okay. So first one is on bottom if I'm talking about. On bottom, you are talking about the force. Can anyone tell me better what will be the force? Pressure will be equal to how much better? Delta P will be equal to rho G into your H. Isn't it? And force at bottom will be equal to, force at your bottom will be equal to your delta P into your area of cross section. So force at your bottom will be equal to rho GH into capital A. That will be the force at your bottom. Clear? In the same way, force on the vertical surface. Number 2. Force on vertical surface. Force on vertical boundary wall or vertical wall. Okay. Force on your vertical wall. So what is the base length, beta? Base length is represented by your B. That means on this element, if I'm taking this one, on this element like this, if I'm talking about this small element on this one, laptop is getting heated. Yeah, only this much part. Okay. So from here, this liquid is, say for example, up to X, and this is of your width of your B, and this width, whatever I'm taking right now, this one is right now for me dx. A small derivation, but I'm not doing in depth of that derivation better. So base length is how much for me? This one, and X value is equals to 0 to X value is equals to H. That is the total liquid which has been filled in this one. So force acting on that small element will be equal to how much better? dF is equals to delta P into your small area. That will be equal to your dA. Okay. Integrating and simplifying the relation, I'll be getting the force. I'm writing the direct relation better. If you need, you can do the derivation. That's not a big issue. Pressure will be equal to how much better? x into rho into your g, because we are talking about only the liquid which has been on the small element, that is nothing but x, and area will be equal to how much for me, beta? B into your dx, because this length into breadth. Okay, length is how much for me? B into your dx part of relation. See, for this one, for this part, this length is how much for me? Your b, beta. From here to here it is b, and this is your dx. So area of that strip will be equal to your b into your dx. So this is your df. Okay, now. So now just integrated all the x terms on one side and simplify the relation. So df is equals to your rho g into b is your constant, and x into dx we can integrate with the proper limits, isn't it? So integral of df will be equal to your f, that is equals to the integral 0 to your h, that will be equal to your df. Just integrate that one. Rho g b will be common. Integral of your x into dx. Limits are from 0 to your h. Integral of x into dx is x square by 2. Substituting and amplifying the limits, I am getting the formula. F is equals to your 1 by 2 rho g b into your h square. This is your ultimate formula to remember to do the numericals. Force on the vertical wall of the container will be equal to your half rho into b. B is your breadth and height is nothing but of this one. Force per unit width will be equal to how much, beta? In this one, if I'm talking about here right now, force per unit width. Okay, that means F by B. F by your B will be equal to your half into rho into G into your H square. So this is your force per your unit width. Clear, beta? Is that clear? Any doubt in that one? Integral of x into dx is nothing but how much for me? X square by 2. Limit substitution if you are doing, you simplify that one part of relation. Clear? Once I know the force, I can even calculate the torque acting on that one, beta. I'm not doing the derivation for the torque. I'm directly writing the relation, beta. Torque acting on vertical surface about its bottommost point. Okay, on your bottommost point, we are talking about your torque. Torque acting on your vertical surface about its bottommost point. That means if this is the surface right now for me, okay, this is also some liquid which is going to do that. Firstly, I'm drawing it, so you can put a picture. Okay, here I'm talking about for this small element. Here we already got the force. This width is how much for me? Dx. From here to here, this is your x. This will be equal to your h minus x. So this is your width b. This is your point O. Force acting on this one is nothing but equal to your df. Okay, now beta. So force will be equal to, what is the torque formula, beta? Can anyone tell me what is the torque formula? Torque formula will be equal to how much, beta? So first let me write the value of force. Force will be equal to rho g b x into your dx. We already written that one. So torque will be equal to your d tau will be equal to integral of your df. Integral of your df. Integral of your df. Limits will be equal to how much, beta? 0 to your h. So force into displacement. Displacement is your capital H minus small h. This force into this perpendicular distance. So integrating on both the sides and simplifying it, will be getting tau is equals to 1 by 6 into rho into g into b into your h. So this is our direct formula, beta. No need of derivation, but you need to remember the application of that one. That will only help you out for doing the numericals. So torque acting on this one is being calculated by the formula. Tau is equals to 1 by 6 rho g b into your h cube. H is your height of that one. B is your width. Clear, beta? Is that clear? So, one more point in this one. Force of application. Force of application. Or I can say that point of application, this one. Point of application, the bracket, force on vertical surface. Okay, so you know the force formula, F is equals to how much, beta? Half into rho into G into B into your H square. The more you practice, you can remember it better. Then torque will be equal to 1 by 6 rho into G into B into your H by cube, H cube, isn't it? If I'm talking about the torque at some vertical position, like say in this one, this is a liquid which is being filled up to a certain height. We are talking about your point of application at which it is ready to tilt. Like say somewhere here you are applying this force, and this vertical distance is, say for example, equal to your y. This is your point O, and this is your breadth of your B. The total height to which it is being filled is, say, capital H. Okay. Now you know that torque at the point O will be equal to your how much at the origin? Torque at O will be equal to your force into perpendicular distance y. Torque will be equal to how much for me? 1 by 6 rho G B into your H cube. That is equals to force. Force is equals to half into rho G B into your H square into y. So rho G B will get cancelled. In the H cube, H square will get cancelled. So it is your 2 ones are 2 threes are. So y will be equal to your H by 3. So that point of application is at a distance of y is equals to H by 3. Clear, beta? From surface, what will be the answer, beta? This is from depth or bottom. Okay. So from surface, if I'm asking, from surface, it will be how much? Capital H minus small y. That is capital H minus of your H by 3. That means that will be equal to how much for me? 2H by 3 from the surface. If I'm talking about this point from the surface, that will be equal to your how much for me? This will be equal to your 2H by 3. This distance will be equal to y by 3. Clear? Just try to remember that application. That's more than enough. Clear, beta? Any doubt in this one? Next one is manometer. Manometer. Instrument which is used to measure the pressure of the gases, isn't it? Like say for example, it is an U-tube type of a structure. Okay, and somewhere here it is connected to your gas chamber. Okay, so this is some point A in which the gas is being filled. Okay, and from here to here there is some liquid, mercury or anything. Okay, it is open to the atmosphere. Somewhere at this point and this point, when the liquid is there, say the pressure will be the same. This one is, say for example, some height, like say H naught. Okay, and in this one some gas is being filled, which is exerting the pressure. this is some gas. Okay, and this distance is right now, say for example, some x, and this height is, say for example, some h. Okay, manometer is nothing but an instrument which is used to measure the pressure of your gas, is known as of your manometer. Okay, so if I'm taking some points right now, so this is your point of your A. Pressure at your point A will be equal to how much, better? PA. That will be equal to your pressure at some point, whatever the given condition we are taking right now. Okay, instrument which is used to measure the pressure of your gas is called as of your manometer. Whatever the point, this is A, this is B, and this is C. Pressure at point B will be equal to pressure at point of your C. Pressure at point P is nothing but equal to pressure of gas, that is equals to pressure at your C is nothing but equal to what, better? Pressure at your B, whatever the pressure we are exerting right now here. So pressure of your gas, pressure at B will be equal to pressure exerted by the gas, that will be equal to the pressure exerted at point C. So at point C it will be equal to how much, better? H rho into your G. Plus it is also open to the atmospheric pressure, it will be your P naught. So therefore I can say that pressure of your gas will be equal to your atmospheric pressure P naught plus H rho into your G, as it is open to the atmosphere, as it is open to the atmosphere. So here atmospheric pressure is being acting, that is nothing but P naught, plus this height of the liquid is also exerting the pressure at point C. So pressure at your point C will be equal to your H rho G plus atmospheric pressure. So pressure at point B is the pressure exerted by this green gas at point B. That is the reason at point B I am taking the pressure at your point B will be equal to the pressure at your point of your C part affiliation. Okay, and next one and last point of this one, and then we'll try to close the session of today. That is about your Pascal's law. Pascal's law. I hope you remember this one, Pascal's law, better from school days you are listening. If there is a pressure exerted by the liquid at one side, the equal and equal and opposite amount of force will be exerting on your other side. Like hydraulic lifts are the best example for this one. This one is like, say for example, very huge piston, and here also there is one huge piston, and it is being filled with certain amount of your liquid here right now. Area of cross sections are different for me. So if I'm exerting the pressure right now from here, F1, isn't it? And this will be exerting certain amount of the pressure on this one, that is F2. Area of cross section of this one is A2, area of cross section of this one is A1. So pressure at this point will be equal to your F1 divided by A1. Pressure at this point will be equal to your F2 divided by your A2. This is some fluid gas, whatever it may be. So as per Pascal's law, okay, P1 must be equal to your P2. That is F1 divided by A1 will be equal to your F2 divided by your A2. At this point and this point, whatever the pressure, if they are inequally, that should be the same. If the areas are not given and radius is being given, so I can write F1 divided by pi into your R1 square is equals to your F2 divided by pi into your R2 square. This pi will get cancelled. So it is F1 by your R1 square is also equal to your F2 divided by your R2 square. Diameters is also given, I can write the same because diameter is 2 times of radius, so R is equals to diameter divided by 2. 2 and 2 anyhow will get cancelled. So F1 by D1 square will also be equal to your F2 by your D2 square part of relation. Clear, beta? If certain load is being kept on this one, beta, if certain load is being kept, then that weight that will be exerting the force on that one. So at that time, I can write this force as here right now. F1 divided by your A1 will be equal to F2 will be equal to what? Balancing the weight of the body, mg divided by your A2. I can even write like this. If certain weight is being kept on this one. Okay, beta? This was the sum of the application of the statics, and the tomorrow session of the class will try to go in detail related to your buoyancy and the accelerated liquid in the containers in the YouTube problems related to this one, and the liquid rotating in a cylindrical structure. This all things we'll try to do in the tomorrow with some good numericals part of it. Okay. Okay, beta. Take care. Bye.